This video is for the subtracting linear functions foldable. We're going to look at it mathematically and then in the real world. So we're going to do the same thing that we did when we added functions. So given the functions f of x equals 5x minus 4 and g of x equals 6x plus 5, we're going to use tabular representations to determine the dependent values of f of x and g of x and use these values to find the values of h of x, where h of x equals f of x minus g of x. So I'm going to start with f of x, and I'm going to plug that equation into the graph side of my calculator. Alright, so delete this one I have in there. We're going to do, not that, 5x minus 4, and then I'm going to pull up the table. Okay, so negative 2, 14. When x is negative 1, y is negative 9. When x is 0, y is negative 4. When x is 1, y is 1. When x is 2, y is 6. Now I'm going to do g of x. So get out of my table, go back to my function, and we're going to do 6x plus 5. Alright, when x is negative 2, y is negative 7. When x is negative 1, y is negative 1. When x is 0, y is 5. When x is 1, y is 11. And when x is 2, y is 17. So now we're subtracting. So I have to subtract these two values. Negative 9 minus a negative 1 is a negative 8. Negative 4 minus a 5 is a negative 9. 1 minus 11 is a negative 10. 6 minus 17 is a negative 11. Now we're going to use symbolic representations to determine h of x, where h of x equals f of x minus g of x, and use h of x to determine the dependent values of the combined functions. So now I have to subtract these two. So something funky happens when you subtract two functions. So we're going to do f of x minus g of x. But what happens here is this negative sign has to distribute. Okay? So what's going to happen? 5x minus 4 is going to stay the same. But negative, and there's an invisible 1 here. So negative 1 times 6x is negative 6x. Negative 1 times a negative 5 is a, that should be a positive 5. Negative 1 times a positive 5 is a negative 5. And then I can combine like terms. So 5x and negative 6x is a negative x. Negative 4 and a negative 5 is a negative 9. So that is my function. Negative x minus 9 is my function for h of x. Sorry, let me move this. And so again, I could go through and I could plug in these values. So you notice I'm keeping this negative sign and I'm putting the negative 2 in parentheses. This negative does not disappear just because this value has a negative sign. So be really careful. That's one of the #1 mistakes I see starting even with algebra kids. Anytime you swap out a letter for a number, make sure that you're putting that number in parentheses to keep the math correct. Okay? So the other way that I can do this, I could just do the calculations, or I can put the function into my graph. I can do negative x minus 9, and I can bring up the table. So when x is negative 2, h of x is a negative 7. When x is negative 1, h of x is negative 8. When x is 0, h of x is a negative 9. When x is 1, h of x is a negative 10, and when x is 2, h of x is a negative 11. So now we're going to connect the results of the tabular representations to the symbolic representations. So using both representations, the difference is the answer to a subtraction problem of the dependent values, or y values, of h of x equals f of x minus g of x is equivalent to the evaluation of the independent values, or x values, of the combined function h of x equals negative x minus 9. Okay, some real world examples here. Write a simplified function of the difference in the size of perimeter between Megan's and Jack's gardens. So first off, I need to write a function for both of their gardens. So if I add all the sides up, so this would be 6v plus 7. This would be 2v minus 1. So I count my v's. 6 and 6 is 12, 14, 16. So 16v, and then count your constants. 7 and 7 is 14, minus 2 is a positive 12. So Megan's garden, the perimeter, M of v equals 16v plus 12. All right, I'm going to do the same thing for Jack's garden. Jack's garden is a square, which means I can just multiply everything by 4. 4 times v, so Jack's garden is going to be j of v, equals 4v. 4 times a negative 5 is a negative 20. Write a simplified function for the difference in the size. So I'm going to take Megan's garden, and I'm going to subtract Jack's garden. Now remember, when we do this, we have to distribute the negative. So negative 4v, negative 1 times negative 20 is positive 20. All it does is it flips the signs. So 6v minus 4v. So my new function, I'm going to name it g of v. 16v minus 4v is 12v. 12 plus 20 is 32. If the difference is 35 units, what is the value of v? So the difference, that's my answer. So if g of v is 35, what's the value of v? So I have an equation to solve. 35 minus 32 is a 3. Divide by 12. 3 over 12 will simplify either to 1/4 or 0.25. So v equals 0.25.